All right, so we worked through 1 and 2 in a previous video, and so I'm hoping you worked through 3, 4, and 5, and we're going to go ahead and check our answers. So we're given the two legs of the triangle, so we're trying to solve for side C. So a squared plus b squared equals c squared. So we're given a and b. Okay, so 36 squared is 1,296. 15 squared is 225, and that equals c squared. You can see the calculator. All right. And then if we add the 1,296 plus the 225, that gives us 1,521. And to undo a square, we take the square root. Now I know we have two answers, right? But we're only going to take the positive principal root. All right? Because we're talking about distance. So it looks like we've got 39 feet for our hypotenuse. And that's a good sign because it's the larger of the three sides, so that makes sense that it's bigger than 36 and 15. All right, for this triangle, it looks like, again, we're solving for the hypotenuse. You see that's the side opposite the right angle, and the two sides that make the right angle are your legs. So we have a squared plus b squared equals c squared. So 22 squared plus 48 squared equals c squared. 22 squared is 484. 48 squared is 2,304. Right? If we add those together, we get 2788. And to undo a square, we take the square root. So 52.8 meters. All right, let's try the last one. It looks like we're missing a leg, so I always let it be a. So a squared plus b squared equals c squared. We're missing a, but we're given the other leg, that would be 10. And this is equal to 12 squared. So we have a little equation we have to solve. So a squared plus 100 equals 144. We'll have to subtract 100 before we can look at the square root symbol. And to undo a square, we take the square root. We're only looking at the positive principal root. All right, if they ask you to round it, you're going to have to hit the change key. So it looks like 6.6. Right, if they ask you to round to the nearest tenth, so 6.6 centimeters. All right, for the two word problems, it's just an application of Pythagorean's theorem. So they talked about a park that's going to be a square. So if it's a square, it's the same distance on all of the sides. And they want to put a diagonal sidewalk. So they want to know the length of the sidewalk. So we know the two legs because there's my right angle. So those are a and b, and we're going to be looking for c. So a squared plus b squared equals c squared. 300 squared plus 300 squared equals c squared. If you square 300, that's 90,000. And another 90,000. That equals c squared. If you add those together, you'll have 180,000. And to undo the square, we'll take a square root. Okay? So the square root of 180,000 is 424.3. Okay, so C is 424.3 feet, but they said round to the nearest whole foot. 424 feet is going to be the length of the sidewalk. And then the last question, looks like they have an antenna, and there's a cable that goes from the ground to the top of the antenna. And oh, you can't see this. This is 60 feet. This was off of an old final exam question, and I just cut and pasted the picture. That should be 60 feet. All right, so do you see that we're missing the leg right here? There's my right triangle, and I'm missing a leg. So I'll do it over here. So a squared plus b squared equals c squared. We're missing a leg. Right, here's my right angle. They want to know this side. So I'm going to let the side that I know be the 60 squared. You couldn't see it very well, but that's 60. And then the hypotenuse is that wire. That's 168 squared. So a squared plus b squared is c squared. All right, so plot our calculators. 60 squared is 3,600, right? And then 168 squared is 28,224. Okay, so it's just a little mini equation. So we'll subtract to undo addition. Okay, and then to undo the square root, or to undo the square, we take the square root. So the square root of 24,624 is 156.9. So it looks like the antenna is 156.9, one decimal place, feet tall. All right, so hopefully you tried those. If you have any questions, let me know, and I will see everybody Tuesday. Have a good weekend.